So 2 times 2 times 2 times 2 times 2. Okay? 2 multiplied by itself 5 times is 32. So the opposite of that is a question. What number multiplied by itself 5 times gives you 32? And the way you express that is that you'd go 32 to the 5th. It's the 5th root. And that happens to be 2. So, because in mathematics there's some beautiful patterns, there's actually a way that you can work out the 5th root of very large numbers in your head very quickly, and you don't have to use a lot of computing power, brain power. So Brady, if you take any double-digit number you like and multiply it by itself 5 times, and you tell me that number in English from left to right, and I write it down, I will be able to tell you what your original number was. Okay.
Okay.
Okay, you got a number?
Yeah.
Is it big?
Yeah, it's big. You ready?
Okay.
79 million.
Wait a minute. 79 million?
235,000.
235,000?
168.
168. So your number is 38?
Well, yes, it is.
It is?
It is.
Okay.
Very good.
How'd I do it so quickly? I'm a genius.
We're going to...
Well, obviously not. I did it because there's a pattern in the numbers. Okay? So, it's actually to do with a wonderful mathematician, Euler. This is Euler's theorem. I'm not actually going to write down what Euler's theorem is. I'm actually going to show you a result from Euler's theorem. For any number a raised to the 5th power is equal to some multiple of 10 plus your original number a. So you can get that from Euler's theorem. Now that's not the theorem itself, but I just want to cut to the chase here. So let's actually do an example. So let's do 47 by the 5th power. Okay, so 47 by the 5th power, actually we can write it as 22,934,496 times 10 plus 47. So if we expand this out, well, a number times 10, you put a 0 on the end, right? So it goes 229,344,960 plus, and if we do, you know, what we do in primary school, plus 47. Look what you got at the end. 0 plus 7, 7. So what that means is, any number multiplied by itself 5 times, the last digit doesn't change. So for me to know what the last digit of your number was, I just have to wait to hear you say it. And then I'll write it down. Okay? The first digit, it's a bit harder. The first digit, you've got to memorize all the powers of the 10s to the power 5. So that's 100,000. 20 to the 5 is 3 million. 30 to the 5 is that. 40 to the 5 is that. 50 to the 5 is that. 60 to the 5, that. 80 to the 5 is 3, 2, and 90 to the 5. Now an interesting point here, all right, is that these numbers, you can notice 10, 1, 20, 2, 33, 44. See that? These numbers are all the same. It goes 5, 6. It's the same as that number there. And the reason why is because of that, if you think about it. So when you said the number, Brady, all right? So you said 79 million. Automatically, I thought 79 million. So I know that's between 30 to the power 5 and 40 to the power 5. Okay? And then you went on and did 235,000. I kind of tuned out at that stage. I wasn't really paying attention. Don't take it personally. I was just waiting for you to hit the jackpot at the end. So if you have someone who like reads out the number, who's like an accountant or something, or an engineer, is an engineer and just kind of gives you a rough estimate, you're stuffed.
That's still a big ask to memorise all that.
Is it? It didn't take me that long. I think you just have a feel for the numbers, but it doesn't have to be that precise. You just
need to memorise.
Yeah, you just need to know that it's anything between 3 million and 24 million. You know, you don't have to be that precise. Anything that's greater than 100 million. You know, when I go to schools, if I do this for school kids, they always pick something in the 90s. But the 90s is so easy because it's just anything greater than 6 billion. So if they go 8 billion, you just go 9. And you just wait till they say the thing at the end. The hardest ones are actually down here. And it's actually hard in the transition. I had trouble quite a bit. Believe it or not, a lot of kids love to do 69 to the power 5. And that one was hard because it crossed over from 777 million up to 1.7 billion. And that was a bit hard, but I got used to it.